Good morning, good afternoon, or good evening, wherever you are. My name is Karen, and welcome back to Through Inquisitive Kids. Today, our lesson is called Using Corresponding Angles to Determine Parallel Lines, where we will be proving parallel lines using the properties and the definition of corresponding angles. So let's get started. This is part 1 of exploring the conditions of parallel lines. If you want to be notified when we upload part 2, be sure to subscribe. The 3 learning goals for today is to understand the concept of corresponding angles, to determine pairs of parallel lines using corresponding angles, and to understand and master parallel postulate and use it to solve problems. Introduction, review and think. Two straight lines CD and EF intersect, as you can see in the figure. What relationships exist between the angles that they form? So what relationships do you see between angles 1, 2, 3, and 4? Well, first we see angles 1 and 2. They form a linear pair. A linear pair is when a straight angle, which is 180 degrees, has a line running through it that cuts it into two separate angles. And these two separate angles add up to 180 degrees as well. So that is the definition of a linear pair. Especially when this is not covered in the slides, but especially when I'm giving extra information like this and when I'm defining extra things, it's always good to be taking note and paying attention. So if you have a piece of paper anywhere, I recommend you write the definition of a linear pair down. All right, and with that, we're going to move on to our next pair. Our next pair of angles is 2 and 3. Again, they form another linear pair. 3 and 4 and 1 and 4 are also linear pairs. They are also each other's supplementary angles. Two lines AB and EF intersect. What relationships exist between the formed angles? So out of 1, 2, 3, and 4, what other positional relationships can you spot? Well, 2 and 4, for example, they are vertical angles. So this is what we learned in the previous lessons. Vertical angles are the opposite pair of angles that are formed when two lines intersect each other. Another example of vertical angles would be 1 and 3. The property of the vertical angle is that all pairs of vertical angles are congruent. As shown, a decoration worker is nailing wooden strips to a wall. If wooden strip B is perpendicular to the side of the wall, so I should draw this down. This is perpendicular. What is the angle between wooden strip A and the edge of the wall so that wooden strip A can be parallel to wooden strip B? So if A and B were parallel to each other, what is the measure of the angle right here in order for it to be parallel? That is the main question we will be focusing on today. This is the focus question of this lesson. As shown, 3 wooden strips intersect to form angles 1 and 2. Strips B and C are fixed, while A is not, which means that B and C are fixed where they are. They cannot move, but A can move. So B and C, and A is right here. And these 3 wooden strips form the two angles 1 and 2. So when angle 1 is greater than angle 2, this is what it looks like. Lines A and B are not parallel. When angle 1 is equal to angle 2, this is what it looks like. Lines A and B are parallel. But again, when angle 1 is less than angle 2, this is what it looks like, and lines A and B are not parallel. So the only scenario where lines A and B are parallel is when angle 1 is equal to angle 2. Corresponding angles. Find the positional relationship between angles 1 and 5. Here 1 and 5 are highlighted in red. Their positional relationship is that they're both on the right side of line EF and that they're above AB and CD. We can simplify this so that we only see angles 1 and 5. This is what it looks like without all of the other angles getting in our way. Think, angles 1 and 5 are corresponding angles. Other pairs of corresponding angles would be 2 and 6. They're both on the upper left corners. 3 and 7, bottom left corners. And 4 and 8, which are the bottom right corners. Now here's a variation. In the figures, angles 1 and 2 are corresponding angles. And their special characteristics are that corresponding angles, I'm going to switch this out for corresponding angles appear in an F-shaped figure. So see how each of these figures here kind of look like that letter, the capital letter F. So whenever you're given a geometrical figure and you want to see, if there is any corresponding angles that I can spot here, look for signs of a F-shaped figure like this, where two lines are both intersected by a third line. Using corresponding angles to determine parallel lines. The methods of drawing parallel lines using straight and triangular rulers. Our first step is to set. We set the triangular angle on the piece of paper or whatever you have. Next, we take the straight ruler and we overlap them on this one line. Then we shift it along. This is a bit not centered, but you get the idea. We're supposed to shift this along this ruler, and then finally we draw. In the process of drawing, what role does the triangular ruler play? Well, here we have a model of two triangular rulers. The triangular ruler is there to make sure that these angles, these corresponding angles, are the same measure. This allows CD and AB to be parallel. Do you have a method to determine whether a pair of lines are parallel out of this conclusion? That triangular rulers make sure that these corresponding angles are the same. Now I'm going to show you a transformation. I want you to answer the three questions. What kind of transformation is shown? During the process, which angles stay equal? And what is the positional relationship between A and B? So here's our line B, our triangular ruler in line AB. So this triangular ruler is moving upwards until we have a nice point where it wants to stop, and along it we trace line A. This is angle 1, this is angle 2. So I want you to pause the video and answer these three questions. What kind of transformation is shown? During the process, which angles stay the same? And what is the positional relationship between A and B? The angles that stay the same was angles 1 and 2 because these were the same interior angles of the same triangular ruler. So angles 1 and 2 stayed the same. And because they are also corresponding angles and that they are the same, we know the positional relationship between lines A and B is that they are parallel. When a transversal, AB here is the transversal, the third line that crosses two lines. When two lines are crossed by a transversal, and when the corresponding angles of those two lines, And when the corresponding angles that are formed are equal, it means that the previous two lines, A and B, are parallel. Here's another question. Based on the transformation process, can you find a method to determine that the two straight lines are parallel? So here's our conclusion. Our method 1 to proving that two lines are parallel. If two lines are intersected by a third line and the corresponding angles are equal, then the two lines are parallel. Mathematically, and this is from the figure, if angle 1 and angle 2 are the same, then L1 and L2 are parallel, because we know that lines are parallel if corresponding angles are the same. Always remember to include your reasoning in a pair of parentheses after you write that step. Let's do some practice. Below, if angle 1 is equal to 55 degrees and angle 2 is equal to 55 degrees, are lines A, B, and CD parallel, and why? Pause the video and see if you can write down a proof. When two lines are parallel, corresponding angles are equal. Here, angles 1 and 2 are corresponding angles, and since they're both 55 degrees, we know that lines A, B, and CD are parallel. Here's a variation. As shown, angle 1 is equal to 55 degrees, and angle 2 is equal to 125 degrees. Are A, B, and CD parallel now? Why or why not? Well, we can first create a corresponding angle for angle 1 or angle 2. For example, let's pretend that there's another angle 3 right here. We know that CD is a straight line, which also means it is a 180-degree angle. If angle 1 is equal to 55 degrees, then we could do 180 subtract 55, which is equal to 125. Angle 3 would have a measure of 125 degrees. And since angle 2 is also 125 degrees and angles 2 and 3 are corresponding angles, we know that lines A, B, and CD are still parallel. However, there is another way we can do this. We can also create a corresponding angle for angle 1. Let's say angle 4 was here. Using the same steps, we know that angles 1 and 4 are the same because we would find out that angle 4 is equal to 55 degrees, and 1 and 4 are also corresponding angles, which means that A, B, and CD are in fact parallel. When two lines are parallel, corresponding angles are equal. Here's another variation. As shown, A, B, and CD are intercepted by EF, and we know that angle 1 is equal to 55 degrees. Add a condition so that AB is parallel to CD. What other condition do we need to know so that AB parallel to CD is valid? Well, any other condition such as if angle 5 was equal to 55 degrees would be a possible condition, but that's not the only answer. If 55 was a condition, using our property of vertical angles, we know that angle 3 would also be 55 degrees. And since angles 1 and 3 are corresponding angles, we know that AB and CD would in fact be parallel. But if we gave anything other, such as angle 2 was 125 degrees, that would also work because that would be using our knowledge of supplementary angles and linear pairs. So there's different ways to answer this question really. But angle 5 is equal to 55 degrees, that's a possible solution. Two lines that are parallel to the same line are parallel. This is the third section of this lesson. The steps to creating parallel lines. First, you set. Next, you overlap with a straight ruler. Next, you shift along that ruler. And then finally, you draw that parallel line. So, how many lines can be drawn through point C? Point C is labeled here. That is point C. Well, let's see. Any line, but we can rotate it in different angles. So there's an infinite amount of lines that can be drawn through point C. How many lines are parallel to AB that can be drawn? Well, there's an infinite amount. All of these in red are all parallel to AB. There's also an infinite amount of lines that can be drawn that are parallel to line AB. But how many lines can be drawn through point C that is also parallel to line AB? There's two conditions that we have to think about. So rotating this line with a pivot on point C, we can rotate it until it is parallel to AB. And there is only one line that is both drawn through point C and parallel to line AB. A straight line drawn through point D parallel to line AB. Is it parallel to the line from question 3? Well, if a straight line is drawn through point D that is also parallel to AB, as shown, let's call it line B, is it parallel to this pink line? Yes, it is parallel, because if you think about it, if this line is parallel to line AB and this line is also parallel to line AB, then they're essentially parallel to each other. But I want you to think about a way you can prove it more mathematically. Out of reasoning and explanation, how can you prove that these two lines are parallel to each other? This will be extra homework if you would like the challenge, and if you have an answer to it, please feel free to share it in the comments down below. I would love to hear what you have to say for this question. But anyways, our conclusion is that there is only one and only one line parallel to a known line that passes through an exterior point. Here's our conclusion. There is only one and only one line parallel to a known line that passes through an exterior point. The transitivity of parallel lines. If two lines are both parallel to a third line, then these two lines are parallel. Such as in here, if line A is parallel to line C and line B is parallel to line C, then both lines A and B are parallel. Class summary. We learned that when we find corresponding angles, it's often in a F figure. And when corresponding angles are equal, two lines are parallel. There is only one and one line parallel to a known line that passes through an exterior point. Two lines are parallel to each other if they are both parallel to a third line. Again, today we understood the concept of corresponding angles. We determined pairs of parallel lines using corresponding angles, and we understood and mastered parallel postulate and used it to solve problems. Thank you so much for watching through Inquisitive Kids. If you found this video helpful or if you enjoyed it, please share it with your friends, your family, and make sure to subscribe as well. Part 2 to this lesson will be coming up, so again, you can subscribe to stay tuned. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.